All right. So on Friday, we talked about just regular addition, subtraction, and what's called scalar, SC. This is scalar multiplication, SCALAR, scalar, when you're just multiplying a number, which is simply if you're going to do 2a, then you're just going to multiply 2 times all 4 elements of a. That'd be 4, negative 14, negative 10, 6. On your paper, try 5b. I'll give you that. When you do a scalar multiplication, it will not change the dimensions of a matrix. Both of those are 2 by 2 matrices. All right. Anybody volunteer for 5b or for for number 2?
Negative 30.
Negative 30.
20.
20.
5.
And
Negative 55.
perfect. Just multiply them all by 5. We usually read matrices going across each row, so getting that habit across. All right, so if you're going to do 3a plus 4b, then you're going to need to do 3 times a, 4 times b, and then add the results. If they weren't the same size, there's no need to even bother starting it because you couldn't add them. But they are the same dimensions, so you will get a 3a plus a 4b, and then you can add those two together. So try that real quick. This is one of those you could do in the Desmos calculator if you wanted to put that in, but with a 2 by 2 and small numbers, it's not so bad to do it by hand. Somebody want to go ahead and tell me what 3a would be? Volunteer out there.
Six. 20. Negative 21. Negative 15.
Yes.
9.
Excellent. And who wants to do 4b? Anybody different want to try 4b?
I'll do it.
Okay.
All right. It's negative 24, 16, 4, and negative 44.
Right. Perfect. So adding them together now is just element to element. The 6 and the negative 24 would make a negative 18. Negative 21 and positive 16 is a negative 5. Negative 15 and positive 4 is negative 11. 9 and negative 44 is negative 35. Is that right? So that would be, and again, if you put that in your calculator and type the 3a plus 4b into that Desmos calculator, it would give you that final answer. Won't give you these. You'd have to do just the 3a separate. All right. So moving slowly to the next side. Matrix multiplication does not work like you think it should. You can't just multiply across like we do add and subtract. when you multiply two matrices, when you have an A by B matrix, and you multiply it with some matrix that is C by D, first thing, these two numbers have to be equal. B has to equal C, or you cannot multiply it. And then the result of the matrix, as long as those two are equal, your first dimension will be the A, so you'll end up with an A by D. So in practical terms, if you have a 5 by 3 matrix and multiply that with a 3 by 2 matrix, you can do that. They don't have to be the same dimension. As long as those two are the same, which they are, your result is going to be a 5 by 2 matrix, the ending numbers. So you know the dimensions before you even multiply them. So in your head or on your paper real quick, what would be the resulting dimensions when you multiply all of these matrices? Welcome, getting you guys on the roll. I'm going to take roll again towards the end to make sure I got everybody, but all right, so like I said, as long as you have the two the same, then the result will be the outside numbers. So this would be a 3 by 4 times a 4 by 6 is a 3 by 6. Who wants to give me the next one?
It's 3 by 5.
Right, those threes match, so it'd be a 3 by 5, correct. Next one, somebody different?
A 2 by 2.
Yep, the 5s match, so you get a 2 by 2. What about number 4? What do you notice about the two numbers in the middle?
They don't match.
Right, so this is impossible. If you tried it with your calculator, it would give you an error. Cannot do that. Number 5 is a
7 by 1.
7 by 1, perfect. What about number 6? Who's got that one?
I don't know if this is right, but would it be a 1 by 4?
That is exactly right. Yeah, the 1 by 5 and the 5 by 3 would make a 1 by 3. Multiply that with a 3 by 4, you would end up with a 1 by 4. Now, in matrices, there's two properties that you should know: commutative property and the associative property. Commutative property says that, like in regular numbers, 3 times 4 is the same as 4 times 3. Right? No big deal. In matrices, doesn't work, because you can multiply a 3 by 4 times a 4 by 6, but you can't switch that around and do a 4 by 6 times a 6 by 4. Or I mean, sorry, not a 6 by 4. 4 by 6 times a 3 by 4. They won't match in the middle anymore. And even if, like this one, you could switch around and do a 5 by 2 times a 2 by 5, but it's still not going to be the same answer. The way matrices are multiplied, it wouldn't work out the same. So commutative property does not work in matrices. Associative property says it doesn't matter what order you multiply them in. So here, for the associative property, you could multiply these two first, take that answer and multiply it by the third one, or you could multiply the second two first, but then you can't take that answer and multiply it by the first one. You have to take the first one, the 1 by 5, and multiply it by the answer, the 5 by 4. You still have to keep them in order, but you can multiply any pair you want to first, as long as they'll multiply. All right, so what's a 4 by 4 times a 4 by 4? Remember, if you square a 4 by 4, you have to multiply it twice. So you would get a 4 by 4, but you just can't square all the numbers inside of it. So let me show you why all of that works, or how all of this works. As we wait. Everything's moving so slow today. Okay, so first matrix is a 2 by 3. The second matrix is a 3 by 2. So yes, we can multiply them. And the results I'm going to get, put it down here, is a 2 by 2. 2 rows, 2 columns. 2 by 2. When you multiply matrix, you multiply 1 row times 1 column. So if I multiply the first row times the first column, that's going to give me the answer in the first row, first column. It's just going to turn out to be one number. So you're going to take these 3 numbers in the first row and multiply each one of them times their corresponding 3 numbers in the first column. And that's why these 2 numbers have to match. Because if you have 3 numbers here, you have to have 3 numbers going down for them to match up with. So you do the 3 times the 2 of the first column. Then you add plus the 1 times the second number, 3, plus the third number, 5, times the third number, 1. So 6 plus 3 plus 5 is 14. So this element is 14. So it's row times column. So now if I want to get the first row second column number, then I need to multiply the first row times the second column of that one. So it's the same 3 numbers here, new row there. 3 times 6 is the first number now. 1 times 4 is the second number. And then the 5 and the 5. 18, 4, 25. 22 and 25 is 47. 47 there. So that takes care of my first row. So now if I want to get, right, first and second column, if I want to do my second row, I have to go to the second row and first column. I'll do it over here. second row now with all the numbers in the first column. The 2 goes with the 2 plus the 4 with the 3 plus the 1 with the 1. 4, 12, 1, 16, 17. So this would be 17. And then finally, second row, second column means you're multiplying second row times second column, which is 2 with the 6, the 4 with the 4, and the 1 with the 5. 12, 16, 5, 28 should be 33. 33. Now, if you were given this problem and just said to multiply, Desmos, putting it in that calculator and multiplying, that's what it's doing. That's why those numbers don't look like you think they might. This, if you're just having to multiply, using Desmos is a good idea. Any questions on that? Tricky or not so bad? So slow moving on. Okay, so 2 by 2, 2 by 2. So the results are gonna be a 2 by 2. So if I want, now I could do, hopefully this is not confusing. If I wanted the number in the second row, second column, all I have to do is multiply second row times second column. I don't have to get them in order. I can get any number in this of these 4 that I want. If I want first row, first column, I gotta do first row, first column. The first one would be -5, 3, plus 2, and 5. So first row, first column, -15, plus 10, -5 goes there. First row, first column. All right. Who wants to tell me what to multiply and add together to get first row, second column? Anybody want to give it a shot?
The -5 and the 2.
-5 would be multiplied with
The -1.
the -1, right? Plus the 2 with
The 2.
the 2. Perfect. That would be +5, +4, 9. And it would go there, right? Because that is first row, second column. Who's got the second row, first column? What do I multiply to get second row, first column?
The 3.
Uh-huh. With
3.
3, good.
And then the -6.
So I can just write -6 times 5. Perfect. So that's going to be 9 minus 30, which is a -21. All right, somebody new want to do the last one? Second row, second column? Who's got a jump out there?
3 times -1
Uh-huh.
minus 6 times 2.
Perfect. Right, so that's -3, -12, both are negative, so -15 there. All right, so, and again, if you throw that into Desmos, it's going to do it really quick for you. Sometimes the numbers are small, it might be easier to do it by hand. So when you have problems like on, I think one of the activities has some variables in there. So, oh, this, sorry, not number 10. 1 by 3 times a 3 by 3 will give you another 1 by 3. And I'm not going to do the whole thing, but you would multiply that, right, for each of your 1, 2, 3 elements. It'd be that row times the first column, add them together. So that would mean you're multiplying 3 things and add them together. First row, second column, add them together. We go there. First row, third column. So if I just needed the number here in the first row, third column, I could do 3, -3. The second number is 5, with the second number, which is +3, minus 2, and the last one's -3. Oop, don't know where that line came from. -9, 15, and +6 would give me 21 minus 9 is 12. So I know 12 goes there. So you don't have to figure them out in order. I think the next one is what I was talking about. Yeah, so if you're trying to solve for x, like you can put this in Desmos and then just look at your answer. The 19, the -1, the -9, they should match, and then whichever one's missing. But if you're doing it by hand, you're looking for the first row, second column number, which is x. So to get that, you would multiply first row times second column. All the others don't matter because those are given. So what is 5 times -1 plus 2 times -3? -5, -6, -11. So the x must be -11. So if you're given 2 to multiply and a variable over here, you got to figure out, just do the operation. There's your answer. When your variable falls in one of the, like this one, then you have a choice. It's in the second column, the x I'm looking for. So I know I have to use one of these 2 numbers in the second column. I can do the first row times second column to figure out x. I just have to make sure I'm setting it equal to the first row, second column number. Or I could do the second row, second column, and make sure I'm doing the second. So if I do the first row, second column, it would be 6 times x minus 1 times 1, and that would equal, first row, second column, has to equal the -13. And then it's just algebra. 6x minus 1 equals -13. add 1, 6x equals negative 12, x equals negative 2. You're done. That's it. Questions on that? Not too bad? Okay. Same idea. I put the x in the first one. So x is over here, and remember I have to use rows, so I have to do the second row. But looking at my matrix, which column should I use? Or which column would be easiest to use to figure this out? Do you want to use -4 and 13, 15 and -2, or 0 and 3? I would say the 0 and 3 will be an easier problem. So if you do 6 times first number times first number, 0, plus x times 3, who can tell me what that should equal in your solutions? So I'm doing, go ahead, somebody say it.
Is it the 21?
Yeah, I'm doing the middle row, the second row, times the third column. That means my answer has to be in the middle row and in the third column. The number I circled both times is 21, right? 6 times 0 is 0, so 3x equals 21, so x must equal 7. The only thing to be careful about with that 0 is if this were x and this were 7, and I was trying to figure out what x equals, well, I can't multiply x times 0 and solve the equation. You'd never know what x is there. You'd have to use a different column. But the way it was fine to use for x. Yeah, so just pick out your 2. I think that's it.